Chang here and welcome to my channel. This is the skill building video series where basically we pick a specific skill and we practice on it to make sure we are completely proficient in it so that next time we see a problem that's very similar, we can solve it right away. So let's begin. Today we're going to be focusing on finding the domain of functions. Domain is all possible inputs. So in this situation, you're trying to find all the possible numbers that if you put it into the function, it still works. It's not going to result in any error or undefined situation. So in order to actually find the domain of functions, what you're going to do is you're going to actually do the opposite. You're first going to assume every single number works, all of them. Then at that point, you're going to start picking special cases. Numbers that you feel like might not necessarily work and start testing them out. And if it doesn't work, then you start taking them out. Now, some common ones to actually pay attention to is if the function is written as a fraction, any number that would result in the denominator being 0, take those numbers out. If it's a square root, a fourth root, a sixth root, any of those, if you find a number that would make the square root, the fourth root, or the sixth root, or any of that negative, those numbers don't work. You're going to take those numbers out as well. Here's the first problem. F of x equals x. Remember that x is the input. So you can actually put in whatever number. Whatever number you put in here, it's going to show up here. It's going to replace the x. Now, again, we're going to assume every single number work. So we're going to assume from negative infinity to infinity. We're going to assume all those numbers work. Afterwards, we're going to try to see if there's any number that might make this result in undefined or error or any of that sort. Now remember, the common ones that we should probably pay attention to is there going to be a denominator that ends up being 0, or is there going to be a square root of negative numbers? Well, this one is just a number. There's no fraction anyway, so we don't have to worry about the denominator being 0. Well, this is not a square root or to the root of 4th power or 6th power, none of that. So in this case, there's no number that would make this like false. There's no number that will make this undefined. So our answer is just going to be negative infinity all the way into infinity. So all possible numbers. For this second problem, f of x equals 1 over x. Whatever you plug in for this input right here, this x, is going to substitute the x in the actual function for that number. All right, great. First, we're going to assume all number works. Negative infinity to infinity. Now we're going to look for special cases where it might not work. This is a fraction. Now, with fractions, we're afraid of it having a denominator equal 0. So in this case, we don't want the denominator to be equal 0. X is there. We don't want x equals 0. So x, we don't want to equal 0. Anything else will make this not work? No? Good. That's the answer. Now, a standard way of writing it is actually negative infinity all the way to 0. And these are parentheses to show that you're not including that number. And then you're going to union two different sets because there's a break, right? That 0 is not included. 0 right here all the way to positive infinity. And that'll be the answer for this one. Here we have f of x equals square root of x minus 3. Once again, assume all number works. Negative infinity all the way to infinity. Then find special cases. Fraction, not a fraction. Don't worry about any number that would make the denominator 0. All right, good. Square root, now we have to worry about numbers that would make the inside of the square root negative. Well, in order to figure that out, first and foremost, let's just figure out what number would make the inside of the square root 0. Well, let's write it here. X minus 3 equals 0. Well, if we add 3 on both sides, x equals 3. Okay, so if x equals 3, the inside 0. That means any number for x where it's smaller than 3, then the inside is going to be negative. We don't want that. So instead of the actual possibility, all possible number being negative infinity all the way to infinity, now we realize all the numbers must actually be 3 or bigger for this to work. So in this case, this does not work anymore. We actually want it to be 3 all the way to infinity. Right next to the 3, we're including 3 because 3 works. We're going to put a bracket right here to include the number that's right next to. And infinity you cannot include, so you're going to put the parentheses. And here is your answer. Here we have f of x equals 1 over x squared minus 1. Okay? Once again, assume all number work. then start taking numbers out, that does not work. Here is a fraction. We don't want the bottom to be 0. So let's focus on the bottom. The bottom is x squared minus 1. We're going to find out what number for x would make this 0, because those are the numbers we do not want to include. So x squared minus 1 equals 0. Now, in this case, we can actually break this down. It's going to be x plus 1 times x minus 1. If you can mentally solve this already, great. If not, here it is. And that's going to equal 0. Now, for two numbers to multiply to equal 0, one of them has to be 0. Well, in this case, what number would make this segment right here, let me box it right here so you guys can see it, equals 0? Well, x plus 1. X must be negative 1. Okay? Now, if we're looking at this one right here, x squared minus 1, what must x be for this to be 0? Well, x must be 1. So if x is negative 1, or if x is 1, it does not work. Good. Now we're going to actually rewrite it. So x cannot equal negative 1 or 1. Other than that, everything else works. Okay, so we have negative infinity all the way until negative 1. We do not want negative 1, so we're going to put the parentheses here. We can't include a negative infinity, so we're going to put parentheses here. And then we're going to union it with negative 1 all the way to 1. So everything between negative 1 and 1 works, right? So we're going to union that also with 1 all the way to infinity. So basically, this complicated thing right here is just saying that all numbers, negative infinity all the way to positive infinity, except negative 1 and 1. Here we have f of x equals square root of x plus 7 over x squared minus 5x plus 6. Okay, assume everything works, negative infinity all the way to infinity. Then find special cases. Well, the top one is a square root. Square root, we don't want any negative number. So the best thing to do, figure out when is this 0, and then find all the number that's smaller than that that would end up being negative and get rid of those. Well, x plus 7 equals 0. That means you subtract 7, you subtract 7, x equals negative 7. So when x is negative 7, the top part becomes 0. That's okay, but that means when x is anything smaller than negative 7, does not work. So let's write that here so we know, okay, this doesn't work anymore. Let's just cross this out because we need x to be greater than or equal to negative 7, right? It can't be smaller than that. All right, good. We're done with the top part. This is the bottom part. This is the bottom part of a fraction. So since this is a bottom part of a fraction, we don't want the bottom to be 0. Find all the number that would make the bottom 0 and get rid of those. We don't want those. Okay? Let's do it right here. X squared minus 5x plus 6 equals 0. That's what we're trying to find out right now. Well, this one we can factor out. That's x minus 3, x minus 2 equals 0. Okay? When is this going to be 0? When x equals 3. When is this section going to be 0? When x equals 2. So this whole thing will be 0 when x is either 3 or 2. Well, we don't want that, so that means we do not want x to be 3 or 2. X is not 3 or 2. Okay? So this is our requirement right here. Everything else we're good. There's no other possibility for error. So let's just erase these and write it in your bracket / parentheses notation so that we are a little more familiar with it. Once again, we're not doing negative infinity anymore because the smallest number we can actually do is negative 7. So let's do this. Let's just write it right here. Negative 7 all the way until what? Let's see. Well, it can go all the way until 2. So this one we're including. 2 we do not want. So let's just put the parentheses right there. Union this. And then we have 2 again, we don't want, all the way until 3. Everything between 2 and 3 works, but then we don't want 3 either. Then we're going to union this with, well, we don't want 3 all the way into infinity will work. So this right here is your answer for this problem.